So, example 1. Okay, so here we are. This actually looks a little more complicated than the right side, so we're going to focus on the left side. What went away? What went away over here? What's missing on this? A sign. A sign what? Squared. There's no sign squareds. Now think about your properties. What ID has sign squared in it? There's only one. All right, somewhere, somehow, that must have happened because sign didn't even know here. Okay, but there was a 3 over here. There was a 3 here. Maybe they factored it out. They did. But how can I factor out a 3 if that's a 4? You rewrite it. So here is what the left side is going to look like. It's going to be 3 sine squared theta plus 3 cosine squared theta. Ooh, I can take 3 out of that. But remember how many were over here? There was 4 over here. So don't forget, you got to rewrite that little single one by itself. Let's factor out a 3. Because remember, guys, factoring really is your go-to on this. We can take a 3 out now. So that's going to be sine squared theta plus cosine squared theta plus cosine squared by itself. And then look at that. What is that in there? What does that equal? In the parentheses. That's right. That's right. So now we're going to have 3 times 1 plus cosine squared theta. We can clean that up. That's just 3 plus cosine squared theta equals exactly what the other side was. Remember, the other side was just 3 plus cosine squared theta. So that's it. We have verified this identity. The only way, guys, we could have moved forward is if we broke up to where we could factor. The only way that we moved forward on this was breaking up a term to factor. And I'm writing that down because you're going to have to do that in your homework, but you're going to have to remember when to do it. We had to factor a 3 out. Okay. Example number 2. Any questions on example number 1? Example number 2 is my favorite example. Let's look at example 2. Okay. So guys, this is one of the examples where some other kids have been working ahead of me, which is totally fine, and they got the same answer but a different route. So if you're working ahead of me, that's cool, and if you do it different, that's great. But if you want to hang on and just work with me, I'm going to show you how I'm going to work this problem. Okay, so obviously we're going to be reworking this. That's just sine squared, or sine theta. There's not too much I can do with this except combine it into one fraction. So that's what I'm going to do. What is this one going to turn into? Very good. That is going to be 1 plus sine theta over 1 plus sine theta. Remember, that equals 1. Okay, so 1 plus sine theta over 1 plus sine theta. Remember, that was 1 minus cosine squared theta over 1 plus sine theta. Cool. Common denominators. Now I'm just going to have one fraction, and it's going to look like this. 1 plus sine theta minus cosine squared theta over 1 plus sine theta. Guys, look at the numerator. Is there anything I can combine at the top? No, I mean, they're not even the same letters. And y'all, that's not a property. Like, that's not a 1 or a negative 1 because that's just plain sine. It's not raised to the second power. So I am totally stuck. So when we're totally stuck, we multiply by the conjugate. So I'm going to multiply the top and the bottom by the conjugate of the denominator. So we're going to multiply the top and bottom by 1 minus sine theta over 1 minus sine theta. So the good news about this is the bottom is easy. 1 minus sine theta times 1 plus sine theta, that's going to be a difference of 2 squares. That's just going to be 1 minus sine squared theta. Oh, and that even equal, what does that equal? What is that? Yeah, that's cosine squared, but we'll worry about that later because we have some work to do at the top. So in this box right here, guys, I am only showing the numerator. Only showing the numerator here. So this is going to be 1 minus sine theta times 1 plus sine theta minus cosine squared theta. I got to distribute. I'm going to distribute a 1 to everything first. That's easy. You just rewrite it down. So 1 times all of that is 1 plus sine theta minus cosine squared theta. All right, now be careful because now we're going to multiply a negative sine theta. So a negative sine theta times 1 obviously is negative sine theta. Guys, what's negative sine theta times positive sine theta? Yes, minus sine theta squared. And then, y'all, a negative sine times a negative cosine squared. We're just going to stick them together, but what's a negative times a negative? So make sure you write a plus sign. I didn't draw my box big enough. Okay, there are actually 2 zero pairs hiding out in here. Did y'all see the first one? What cancels out? Yes, these right here. Those cancel out. Let's cross these out. And then, y'all look, this is negative cosine squared minus sine squared. What does that turn into? A negative 1, that's right. This is a negative 1. So this is going to be 1 minus 1, because that's what those two were, plus sine theta cosine squared theta. There's the other zero pair. That's going to go away. So all of this, the numerator just simplifies to sine theta cosine squared theta. All right, so all of that simplified to this. We are going to rewrite that as cosine squared, the denominator. So this is going to be sine theta cosine squared theta over cosine squared theta. There's no pluses or minuses. I can cancel out that stuff. So we're going to have sine theta equals what the original right-hand side was, which was sine theta. That's it. I'm just going to review these steps for you guys. All right, step 1. Step 1 was right here. We rewrote this 1 so we could combine the left side. If you see a whole number of a 1, you better rewrite it to combine it. And then after we did that, y'all, we got stuck. There was nothing else I could do. So when there's nothing else I could do, that's when I multiplied by the conjugate. Now, when you multiply by the conjugate, you're going to have crazy stuff happening. There's got to be a zero pair somewhere. There might even be two, like what we just had. So, remember, the first thing we did was we combined the fractions. And after that, we multiplied by the conjugate. That's how we approach that. But sometimes you don't have to multiply by the conjugate. Like example number 3. Let's go to example 3. All right, so for example 3, we know that it is going to be 1 plus tangent theta over 1 minus tangent theta. Guys, make sure you pay attention because you're going to do one on your own like this. And this equals cotangent theta plus 1 over cotangent theta minus 1. So it looks like I need to combine some stuff together. First of all, I need to figure out which side to work on. Tangent's like a main trig function, so I'm going to leave that side alone. I'm going to focus on this. Because I can actually write cotangent with those letters. How can I write cotangent with TAN in it? What is that going to look like? 1 over, that's right. So that's totally where I'm going to start. So this is going to turn into 1 over tangent theta plus 1. And the denominator is kind of going to look the same thing. It's just going to be a minus there. Okay, at least they have the same letters. Now, look at these ones. We're going to combine the like term, or we're going to combine the terms, guys. So this numerator, I'll keep it in red. This is going to be 1 over tan theta plus what? How are you going to rewrite that 1? 10 over 10. Good job. Now that we have like terms, we can go ahead and combine the top. 1 plus tan, that's going to be 1 plus tan theta over the common denominator of tan theta. That's as far as I can take the numerator. If I try to do anything else, I'd be working backwards or not having the same letters anymore. So that numerator is going to hang out. I'm going to do the same thing to the denominator. I'm going to go ahead and write the denominator as one term. So this is going to be 1 over tan theta minus what, guys? What's going to happen? What does that turn into? What does this 1 turn into? Tan over tan. Now that they have the same denominator, I'm just going to put the two numerators together. 1 minus tan theta over tan theta. So I had a fraction. I had way too much stuff going on at the top and the bottom. I simplified the top and the bottom as much as I could. Now I'm going to put it back together. So when I put it back together, there's actually going to be 3 fraction bars right here. When you have 3 fraction bars, it is keep, change, flip. Now remember, the numerator was 1 plus tan theta over tan theta. Remember, the denominator was 1 minus tan theta over tan theta. When you simplify the top and the bottom as far as you could take it, this is when you keep, change, flip. And guys, when you keep, change, flip, stuff's going to cancel out and it's going to match. So what does keep stand for? Do y'all remember? Keep the first one. So this numerator, I'm going to rewrite it right here. I'm not going to mess with the order of it. What does the C stand for? To what? Multiply, that's right. And then F, flip. So tan is going to go on top. Multiply by the reciprocal. So that's now on top. And remember it was 1 minus tan. Guys, those are going to cancel out. Then the right and the left side are going to match. You can, right here? Yeah. Yeah, you can. I'm just showing all the steps. So these are going to cancel, and we're going to get 1 plus tan theta over 1 minus tan theta, which is exactly what the left side equaled. We're good. We just proved it. Do you guys have any questions?